guys, this is Mr. Intunza with you again. We're going to go ahead and work on problem number 4 now from your test corrections. Now, this problem right here is asking you to expand. If you're expanding, then what we're doing is we're going to take our properties of logarithms. Remember, there was 3. There was the product property, the quotient property, and the power property. We're going to take those 3 properties and we're going to apply them to each of those problems right here and expand them. So expand means we're going to make them longer, or we're going to break them down in a sense. So we're going to take this problem and we're going to go ahead and break it down into a bunch of little chunks. So let's see how this works, and let's go ahead and get started. Now, notice that this is log. No, there's no number there, so that means it's log base 10. And now it's all this on top is being divided by this number on the bottom. So if we're going to go ahead and expand this, one of the things we can do or we can use is the quotient property, which says that if you're dividing, you take the numerator and denominator and you can go ahead and subtract them. So let me just write the rule real quick right here so you can see what I'm talking about. What I'm talking about is this: log base whatever of some number. If you're dividing this way, what the quotient property says, that you can break this up into subtraction like this, into the log base a of your numerator minus log base a of your denominator. So all we're going to do, since we're dividing right there, we're going to take that and we're going to break it up using this. Okay? So let's go back over here and let's do it. So here we go. So now the numerator is all this. So you got to make sure you keep all that together. So we get log base. So there's nothing there. There's really a 10 there, but we don't write it. So, or if you want to write it, you can write it. You don't have to. So of the numerator, which is x to the 8th, y to the 4th, minus, because it's the quotient property, log base 10 of 10. And like I said, this is not necessary because it's base 10, but it's up to you. Now that we're here, now notice that we have a minus, and we're like, oh, okay, this looks a little simpler, we're cool there. But notice that over here we have 2 terms. These 2 terms are being multiplied, which brings us to another property, which is the product property, which says log of base of some base, and if you're multiplying 2 numbers, you're taking the log base a of the multiplication of any, whatever numbers they are, doesn't matter. That's the same as saying log base a of a plus log base, sorry, I'm going to use another number right here, like c. So log base a of c, log base a of b. So in other words, if you're multiplying 2 terms, whatever they are, variables or numbers or whatever, you can go ahead and break them up into addition. So let's go ahead and apply it over here. So notice these 2 are being multiplied. So let's go ahead and break them up. Log base 10 of my first number, x to the 8th. Since it's the product property, we add. Plus log base 10 of y to the 4th. And don't forget, this is minus log base 10 of 10, so you got to bring that guy down. And I'm going to go ahead and get rid of this guy right here, just so you guys don't get confused. That was just little prerequisite knowledge. Okay, and now it appears like, hey, you know what, that is expanded. That looks like we're probably done. But the answer is no, because we still have this exponent. And the power property says that if you have an exponent and you're taking the log or the natural log of it, we can take those exponents and just put them in the front, because this guy's afraid of heights or something. I don't know. So here we go. So we get 8 log base 10 of x plus, there's your power, so we're going to throw them in the front because of the power property. So we get 4 log base 10 of y minus base, this is the same base, so 10 to what power equals 10? Oh, and there it is. Okay, now you expanded this term, expands into this. This and this are equivalent statements. This expression and this expression are exactly the same thing. This is just expanded form, and this is condensed. Okay, so now let's go over here and work on the next one over here. Let me grab my towel real quick. And I'm back. Okay, so let's do this one now. Now, one of the things you see on this problem is the following. Notice that this is a square root. And remember that whenever we're taking the logs of square roots or radicals, we turn them into exponents. So let's do that right now. So we get, this is the same as log base 3 of, the square root of x is the same as the power of 1/2. So it's going to be x to the 1/2, y to the 5th, all over z to the 5th. So now we're going to take the same approach that we took on the previous problem, which notice that all of this on top is being divided by all of this on the bottom. So we're going to use the same property that we use here to split that one up. And you guys remember what that one was called, right? It was the fancy name for division. That's right, the quotient property. So let's go ahead and do this. So we get log base 3, because you keep the same base, of the top minus the bottom, right? Log base 3 of the top, which is 1/2, x to the 1/2 times y to the 5th, minus, because it's the quotient property, right? The log base 3 of z to the 5th. Now, this statement should look very similar. It looks very similar to the one we did before. So notice that x to the 1/2 is being multiplied, because they're next to each other, to the y to the 5th, right? Y to the 5th. So if we're going to go ahead and expand that to expand multiplication, or the product of two numbers, we're going to use the product property, which says that we can expand this by turning them into addition. So this will give us log base 3 of x to the 1/2 plus, because you're multiplying product property, log base 3 of y to the 5th. But don't forget about this guy. You can't just leave him out. You got to bring him down. So now, this is an expanded form. However, we are not done yet, because notice that we have the exponents again. Exponent right there. And the power property says that we can take this exponent and we can throw it in the front. So let's throw it in the front and we're done. Plus exponent minus another exponent. So let's put them in the front. And that right there, this statement and this statement are equivalent. This one is compacted, this one is expanded. So here it is.